In this section, we're going to be talking about transforming functions. In this video specifically, we're going to discuss horizontal and vertical translations. But before we do that, we need to talk about some vocabulary, and that is the idea of families of functions. We can group functions together in what we call families if those functions have a parent function in common. And what we mean by that is that if we can reduce a function down to just its very basic form or components, then we consider that a parent function. So for instance, we would consider y equals x squared to be a parent function. And then any function that takes that parent function and transforms it somehow would simply be a component of that family of functions. So perhaps we take y equals x squared and we transform it into the equation y equals 3x plus 2. That would just be one member of the family of functions led by that parent of y equals x squared. There are lots of different types of parent functions. Y equals x cubed, the cubic function would be one. Y equals the square root of x, that's another type of function. In the next section, we're going to talk about the function y equals the absolute value of x. So those are just some of the examples of a parent function, but there are many, many more possibilities. So there are actually 3 different types of transformations. Again, in this video, we're particularly interested in translations. In the next video, we'll talk about stretches and shrinks, and then finally, we'll talk about reflections. But for now, let's focus on translations. There are 2 different types of translations, either horizontal or vertical. And of course, if we have a horizontal translation, that means that we are moving our function to the left or to the right. And if it's vertical, of course, that means that we're moving the function up or down. So if you remember back to section 2.1, we talked about function notation, and that's going to come back here. So if we take our parent function and we apply what's called a horizontal translation, like I said, we can either move to the left or to the right. If we're moving to the right, that means, I'm representing the translated function with y, that means that we are taking our original function, which was f of x, and we are shifting it to the right h units. And so we represent that as f of x minus h. And conversely, I don't know what I'm writing there. If we are going to translate our parent function to the left, then our new function, y, would be the original function evaluated at h units to the left, excuse me. And that's represented by x plus h. Now that might be a little bit confusing because you do think normally that if I'm moving to the right, then shouldn't I be adding, and moving to the left means subtraction. And if you're working on the number line, that's certainly the case. But just keep in mind that here for these translations, it's actually the opposite of what you might expect, at least in terms of the horizontal translations. And that's because what this is saying is that we are taking our function, and if we're moving it to the right, then we would have to subtract h units to get back to our parent function. Or if we took our parent function and moved it h units to the left, then we'd have to add those number of units back in to return back to our parent function. Now we also have this idea of a vertical translation, and that works pretty much the same way as a horizontal does, except now we're moving up or down. If you're moving up a certain number of units, we usually talk about vertical translations with the letter K. Horizontal translations, you notice we use the letter H. If we have a vertical translation and we're moving a certain number of units up, we can describe that by saying that y is going to equal f of x plus k, meaning we move k units up. And if it's a vertical translation down, that means that y is equal to the original parent function, f of x minus k. And again, this one's not quite as tricky to remember because the signs on k work about the same way as you'd expect. A positive value of k means you're moving up. A negative value of k means you're moving down. All right, so let's do a quick example. Here I have my parent function defined to be f of x equals x squared. And that's just a regular old parabola. The vertex is at the origin. In my first translation, I'm going to take our parent function f of x, and I'm going to translate over to this new function g of x, where g of x equals x plus 2 squared. Now if you think back to the last slide, we said that horizontal translations get applied to the x-coordinate, and vertical translations are going to get applied to the y-coordinate. So what we have here, let's see what I say, x plus 2 squared. So what we have, since we're applying our translation to x, because it's inside the parentheses, inside that x plus 2, and because it's a plus 2, that means we have this situation here. We've got a horizontal translation 2 units to the left. So if I wanted to graph this, I would then take all of the points that were on my parent function and simply plot them 2 points to the left from where they originally were. And there's my translated parabola. Again, just move 2 units to the left. If instead of being the function x plus 2 squared, I had had the function x minus 2 squared, that would still be a horizontal translation, but it would just be 2 units to the right instead of 2 units to the left. Now let's take a look at this other example. I've got the function h of x is x squared minus 3. Now if you notice that minus 3 is outside what's being done to x. So that means that this function is going to be a vertical translation. And based on the last slide, we know that if k is a negative number, then that means that we must be moving down. And we're just moving down however many units that we have in our equation, and that's 3. So that means if I'm going to graph this function h of x, I just take the parent function and move it down 3 units. So 1, 2, 3. Just bear with me a second. And there in orange is h of x. So again, the red function was a horizontal translation 2 units to the left, and the orange function was a vertical translation 3 units down.